Hey guys, I wanted to talk about section 3, question number 2. So I got a question for that, and thank you for submitting that. So this is the one on, they give you this equation right here, and they told you it was 50 mils of the sodium carbonate and then an excess amount of the calcium nitrate. So first they asked you the net ionic equation, which I know most of you guys know how to do. And just a couple of reminders, Na plus and NO3 are always soluble, so they always create soluble compounds. And they asked, are there any other ions present? So they gave you the Na plus and the NO3 minus. And because the CaNO3 was in excess, right, you're going to have some Ca left over as well. So the other ion that you would add would be the Ca plus 2 ion. The next question was C, and they asked you how many moles of CaCO3 are from the original equation. So they told you in the table that you have 0.93 grams, so you're just using straight stoichiometry to relate the CaCO3 down here using this equation up here. So it's a 1-to-1 molar ratio, so I just took 0.93, divided it by the gram formula mass, and multiplied it by the molar ratio here. And that is the answer to that one. And then the next question was, do you agree, disagree on whether or not if you have a wet filter paper, meaning your precipitate has water on it still, will you give a false high or a false low on the concentration? So the student said that it would be a false low. So my answer is I disagree, because if you have water on the CaCO3 solid precipitate on the filter paper, it's going to give you a reading greater than 0.93, which is going to give you a greater amount of moles, which is going to give you a false high on moles and thus molarity. Okay, E was, will the solution conduct electricity or not? So again, the solution that we're looking at is the one from B, right? And it will conduct electricity because you have mobile ions. So whenever you have mobile ions, the solution will conduct electricity. F was a tricky one, and it was actually a question that was on the exam last year. For you, it won't be on there. However, I want to take you through it because it becomes important later on. So they said, what's another measurement to determine the amount of OH? And one way we could do that is we could do a pH measurement. So that's considered a laboratory procedure where you measure the pH. If you measure the pH, remember you can back calculate it to the pOH using this equation. And then you can use this equation to get your pOH to your concentration of hydroxide. So that was the answer to F, number 1. Number 2, they said, how would you figure out the CO2 based on your answer? So there's a number of different ways you could have written something. You could have said like precipitate or something like that. But just going with the pH measurement, they gave you this equation in the problem. And because we know the concentration of OH, right, we're going to also know the concentration of HCO3 because that's going to be the same. So at equilibrium, remember, those are going to be equal to one another based on the equation that they gave you. They also gave you Kb, so you're just going to solve for X, which is the CO3. And then lastly, on G, they said which concentration is going to be greater, this ion or this ion. And remember, this was the product, and this was the reactant. And the Kb they gave you is really small, 2.1 times 10 to the negative 4th. So therefore you have much more reactants than products. And again, the carbonate ion was the reactant. So your hydrogen carbonate would be much smaller. All right, thanks for submitting that question.